Everybody was here yesterday. So here we go. So lesson 2.2, exponential modeling with percent growth and decay. So this is really, like I said, a homework assignment because we've already done our journal. So we're just going to set some of these up and you guys are going to be the mathies because I'm done mathing for the day. So if $130 is invested in a savings account that earns 4% interest, which of the following is closest to the amount in the account after 10 years? $130 represents what, Hayden? Beginning amount. So $130 represents P. 4% represents what? Which is your rate. So I'm going to write it as 0.04. And because it's growing, what am I going to put in front of it? A 1. That was supposed to look like GR for growth rate. That didn't turn out very well. GR for my growth rate. Okay. What's my time? How long are we doing this? 10 years. So who feels like they can spit out the equation? Michael. I don't want the answer yet. Tell me the equation.
130 times 1.04.
Perfect. And what'd you get?
I got 192.
Which is close to what answer?
Number 2.
Exactly. Yeah. How do we feel about that? Good? Okay. Who feels like they can do the fruit flies? Tell us what everything is and set it up. Population of fruit flies. Who wants to talk about it? Max, you got it?
Yeah.
You got it? Go, Max.
50 is the P.
50 is the P.
And the rate is 0.06 and the growth rate is 1.06.
Perfect.
Per day. So times 1.
Which of the following is closest?
Double.
We're waiting for the population to double.
So wouldn't you put it, raise it to X and then go to your table?
Yes. And when our population doubles, what are we looking for? We're looking for the final amount to be what? About 100. So we just don't know what T is. We're going to just call it X for right now. So let's see. We have 100 equals 50 times times 1.06 to the power of X. So that's our equation. But if you put this into your Y equals and do just what Michael said, go to your table of values. What is your input value? What is your X value? About how many days does it take for your Y to equal 100? 12 days. When X equals 12, what is your output on your table of values? Go ahead, Michael.
Well, my table's like all messed up.
Let me see it.
Skipping numbers.
That's because someone has gone in and messed with your table. Table set. So we want your table to start at negative 25.
You know, you can like, if you go to table set, you can like jump around. Huh?
There you go, bud.
Thank you.
Uh-huh.
Second.
Yeah, can you come and grab a pass? Aiden, you can go as well. So she gets back. So you can go. I thought Zach wasn't back yet. What is Y? So in 12 days, what did you get for your output Y? What's your number? In 12 days, you get what? Yeah, 100.6, right? Okay. If a radioactive substance is quickly decaying at 13%, so if it's decaying 13% per hour, what is my decay rate? 12. Do you see where it says X equals 12? So what is my decay rate? 1 minus, go ahead. 0.87, good job. Okay. So how much of a 200-pound sample remains after 1 day? And it's decaying per hour. So 200 is our beginning amount. Our time is 24, right? Because there are 24 hours in a day. What's our equation? Good job. And what did you get? 7.1. Can you guys do 4, 5, and 6 by yourself, you feel like? Yeah, let's look at those word problems on the back. I would like to do number 7 with you. So it's talking about Red Hook. Are we all there? On page 2? Okay, back page. So Red Hook has a population of, so Red has a population of 6,200 people, and it's growing. So its growth rate of 8% is really 1 point, help me out. Thank you. Good job. 1.08. Rhinebeck, the other town that we're talking about, Rhine, has 8,750 people, and it's growing at a rate of 6% per year. So what's its growth rate going to be? 1.06, right? So in how many years to the nearest year will Red Hook have a greater population than Rhinebeck? So we want to know when the Red Hook population is going to be greater than the Rhinebeck population. So I'm going to write an inequality. 8750 times 1.06 to the t. So there's our inequality that we're using. And it says solve it graphically. Well, we're just going to make a sketch. This is going to represent our time, and this is going to represent our population. So if I go up to 55,000 or 50,000 to start, so this is 25,000. Where does our our Red Hook population begin? What's the beginning value for Red Hook? 6,200. So that's like 1/3 of 25,000. Are you guys okay with that? And it grows at a rate of like 1 something. I don't know. So I'm just going to do this. I'm just making a sketch. I just know that this is the 6,200. Okay. Now let's go to the next town, Rhinehook. Well, they're at 8750, so that's going to be above. And I know that somewhere along the lines, those are going to intersect. At some point, they're going to intersect. And I need to figure out when that is. How many years? So I want you to graph these either in your calculator or in Desmos. You can put them both in your calculator. Under your y equals 6,200 times 1.08 to the power of x, and y equals 8,750 times 1.06 to the power of x, and then go to your table of values and find out when they intersect. It's not going to be a whole number. It's easier to graph it and find their point of intersection. It's easier actually to do it in Desmos. So So I'm going to freeze my screen and go to Desmos really quickly. But I think Max is going to beat me because he was already in Desmos. Max, that's cheating. You got a head start. It's called adapting and overcoming, right, Max? Being smarter. He's not disrespecting me. I think it's great that he's. What is our time? I didn't read it. I didn't finish reading it. Yeah, you mean as your answer? I got 18.4. See how I wrote them right there? Y equals 6200 times 1.08 to the power of x. 750 times 1.06 to the power of x. Yeah.